to introduce to you now robotically built houses from Asia. Homegrown, developed in our nearby region, 5 hours flight from Thailand, maybe 6, right? Technology that actually has been able to see real production. We have with us now Mr. Aidan Flint, the Chief Financial Officer of FBR. Listen to him, hear what he's shared with you. He's going to show you the products that they have created. They have started to build houses in Western Australia. People have started to live in those houses, I think. And the house owners are very happy. We talk about customizedly designed houses for the house owners. So I'll hand you over to now to Mr. Aidan Flynn. Thank you.
Thank you very much. Firstly, thank you for having me in Thailand. This is my first time ever visiting your country, so thank you for having me. It's not too far to come from Australia. It's a little bit more than 5 hours, but it's pretty close. I'm a little bit jet lagged despite that, so apologies despite that for my travels. Yeah, so I'd like to talk to you today about robotically built houses. Thank you. Specifically, you know, we see what we see in Australia is really what I can talk about. We're still learning about the rest of the Asian construction market, and I'm here to learn and collaborate. But I can share with you today our construction technology experience. And at the moment in Australia, as was just said, we've built houses with a robot and people are living in them. And it's not just us that's doing it, but I'll focus specifically on our technologies in the second part. The company I'm from is FBR. It's short for Fast Brick Robotics. And what we've developed, you can see on the screen here, is the world's only real fully autonomous bricklaying robot. It's built onto the top of a standard Australian truck base, so it can drive just like a truck can to site. And when it gets there, it's ready to lay the bricks just like a human does, except it has a telescopic boom and robotic precision to do it. And that's what's happening now, and that's why houses now can be built by robots and don't have to be built the traditional ways. But if we take a step back about houses and how they're built, houses have evolved over the last millennium, but on the other hand, they really haven't evolved that much. The house that we had 1,000 years ago is not that different when you think about it. And what's even less astonishing is the way that we build houses over the last 1,000 years really hasn't changed that much. It's still a very simple process. We still basically normally just use our hands, put it together bit by bit, and it still takes quite a long time. When you think about what you put into your house, the technology you buy and then fill your house with, the iPhone, the iPad, the microwave, the flat screen TV, the little vacuum robot that goes around, your house, your life is full of technology, but the house you built, you didn't use technology to build it. And our company is fascinated with why is that so? Why is this technology not pervaded the construction industry? And so we set about to build a technology and actually implement it to make that happen. And when you combine this sort of context in Australia particularly, where you have an actual shortage of houses compounded with a chronic shortage of people to do the labour to build the houses, well then you've not only created a need for technology, you've created the absolute necessity, the demand for it to happen right now. In the world, there's lots of numbers, but there's up to 1 to 2 billion people who don't currently have adequate housing. And that number's set to grow. Every day for the next 7 years, we need to add 96,000 houses to the world to make sure that everyone has a safe, available place, sustainable place to live. And yet, we aren't applying all this wonderful technology to make sure that happens. The picture you can see on the screen there is from an Australian newspaper article earlier this year. Australia is going through a house shortage, as I mentioned. It's exemplified by this chronic labour shortage. And this article was talking about it. But I like this picture because it sort of explains the difference between manufacturing and construction and the difference between where you put technology to use and where you don't. In Australia, the bricks that you can see on those houses there are made in a factory with robots. They're very highly precisely made. You walk into a brick factory, there's hardly any humans around there because they're all made autonomously with robotics. The cars that you see parked there, that the bricklayer drove to the site to build the house, that was made in a factory. Not in Australia anymore, but by robots, fully automated manufacturing. And what our technology, what our company is focused on is let's manufacture houses instead of constructing them. Let's make them using all the technology you've got. Let's make them quicker, better, faster, and cheaper. The same way we make a car. And we use the car analogy quite a bit when we approach to technology and application. A typical car, which most Australians have, has between 10,000 to 30,000 individual parts in the car. But yet it only takes 1 day to make a car, from start to finish in a car manufacturing facility, which everyone knows and everyone takes for granted. It only takes 1 day. From the days back in Henry Ford, it embraced later robotics, and now it's a well-oiled machine when you can get your car in 1 day. Yet in Australia, the house has far less than 10,000 parts, but it takes at least, on average, these days, 1 year for your house to be built. And we just accept that in Australia. We just think that's normal. It should take a year for a house to be built. But in our company, in our technology, we don't see it that way. The technology is now here. Houses should be built by robots. Now is the time for it to happen. It's for the better, for the humankind, for the embrace this technology. That's not to say there isn't robotics already being applied in the building industry. There is a bit there, but we're just taking, in most places, the first steps. And the advantages of robotics, are quite obvious. It can do it quickly. The efficiency and the speed is self-evident. That's one of the advantages of robotics. It can work 24 hours a day, 365 days a year. It also brings, in theory at least, the precision and quality. No human error, millimetre precision, done right the first time, no rework, which in residential construction, again in Australia, is a big part of the delay. Things aren't done right the first time, so the next person fixes the mistakes of the previous step, and so on and so forth, which is the opposite of manufacturing, where there's no mistakes. Everything's done right the first time at the right time. And we talked about ESG in the previous presentations. The safety factor of robots, the safety benefits is self-evident as well. But despite all those three very, very valuable facets of robotics in construction, what we are finding at the moment is the actual most powerful driver for putting robotics into house building is just the labour shortages. It's filling the gap. In Australia, you pour a slab on the ground to build your house, and it could sit there for 3 or 4 months just waiting for a human to come and put the bricks on it. It's not a matter of being cheaper. It's not even really, at this stage, a matter of being faster. It's just filling the gap. And I appreciate that's not the same in all construction markets around the world, but generally speaking, the trend is for people not wanting to do these types of jobs. Safety standards increase, labour shortages increase as well. And so, with that, technologies have evolved, and the need has put them into the real world. And the steps are baby steps at this stage, but it is happening. And the first sort of robotically built type of houses was really the prefabrication, the off-site modular construction, where companies can build a roof truss off-site, walls, some simple walls, some complex walls, some with services in them already, and have that done in a factory. Now, that has a lot of advantages because you can then assemble on-site in this sort of IKEA fashion. It minimises your on-site construction time, but also to a certain extent it moves the problem from one site to another. Part of the drawbacks with these kind of prefabricated systems is housing often can be quite bespoke, it's quite customised, so having sort of lots of prefabricated walls doesn't always fit together, not necessarily the way an IKEA sort of pack of furniture fits together. The other big problem, which we've seen in Australia, is the logistics of taking these big pieces of equipment from big pieces of modular construction to site. You've got to have big trucks, you've got to have big cranes, and when you get there to assemble them, it might go quickly, but you need a big expensive crane, and that comes with safety risks. The biggest safety risk in Australia in residential construction is when we're lifting things around and tilting up concrete panels and things like that. That can be very dangerous, things can fall over and hurt people. But nonetheless, this is a good technology and it's helping take the steps towards robotically built houses. What's getting even more attention lately and being talked about is the 3D concrete printing space. 10 years ago, 3D printing took the world by storm with little parts for aircrafts and space and everything you can think of, plastic and metal manufacture. More recently, people have started applying that to house building. It's natural to do so, it's a good solution. Doesn't have all the answers though. Essentially, you're doing it on site, which is good, but you're not using exactly an existing product. They're slightly more technical, specific concretes that you're using because they need to cure very, very quickly, because the concrete, as you pour it around or lay it around, has to support its own weight. So it has to harden quite quickly, or you're constrained by how quickly you can print the house. While you're doing it on site, you still need to construct the sort of gantry system around here, and by definition, that gantry system needs to be bigger than the house that you're building itself. It has to be longer, wider, and higher. So it's not an elegant solution in some ways, because you have to build two structures: the printing structure itself, then print the house, then dismantle the printing structure. But nonetheless, particularly in the USA, this technology has been getting a lot of money and a lot of traction, and houses are being built. It can print nice, fancy and curved walls, which have some architecturally pleasing features. Some people like them, some people don't. And then the third area, which is where we come from, FBR, Fast Brick Robotics, is bricklaying robots. So taking it back a step of simplicity. Houses are built with bricks. Let's just get rid of the human. Let's lay the bricks with a robot. So they're trying to use an existing product, which is the brick. They're trying to do it on the existing site, in situ, and they're trying to use the existing architectural plans, the CAD model that most houses are designed with at the moment. Now, there's not a huge amount of those technologies out there. There's a couple on the screen. Some of the constraints, as you can see on the screen there, are the reach. These little robots don't have the reach to build a big house. Some of the constraints are the semi-autonomous mason in the top right-hand corner. That one can only do straight lines. It can't go around corners. It sits on a rail system that has to be set up. So our company set about to task to develop the world's best bricklaying robot. So I'd like to introduce what we've come up with, which is the Hadrian X. It's named after Hadrian's Wall, probably the most famous early built wall in the world. And it's a bricklaying robot. It's fully autonomous. No human hand touches a brick. It's on the truck base. The truck can drive to the site. You don't have to set up any gantry or crane or systems. It is the system itself. It's fully road mobile. It can be operated by an iPad type tablet, as you can see there. It goes to site with a crew of 2 humans, just to supervise it, just to set it up, and of course at this stage one of them has to drive it to site. I'd just like to play a little video to explain it much better than I can show you with a picture. This is in Perth, Western Australia. Thank you. We're very proud of that robot. This is real. This is happening now. What you just saw then... can I just go back to the presentation? Thank you. So that's happening now. Thank you. Oh, thank you very much. We are very proud of that, and it's taken us a long time and a lot of money to get there. We've spent about $120 million developing this technology over the last 6 or 7 years. But we've got it to the point now where we've built houses in the real world. It's really happening. And this is the first journey we're really coming out to Asia to try and start exposing our technology around the world. And for us, it just seems obvious. Why use your hands when you can use a robot to build the house like that? And the beauty of robots, of course, is they can do things quickly. So we can lay, that robot you just saw there is currently laying at about 300 blocks an hour. The blocks that we're laying, that you can see there off the shelf, the sort of large ones we can buy, there's about 10 of them in a square metre, vertical square metre. So if you're laying 300 blocks an hour with a robot, and there's 10 in a square metre, that's 30 square metres every hour of wall that just appears in front of you. So that means for the average Australian house, to do one leaf of bricks is 8 hours, one day. You can build the house, the walls of the house. But that's just the start. This machine that we've got there is designed to go up to 500 blocks an hour. And on top of that, it's designed to go to bigger blocks. Blocks are constrained by the size and the strength of a human at the moment. The blocks that we can take in this robot are 600 millimetres long and 400 millimetres high. That's the maximum size. When you're getting blocks that big, it's very, very hard for a human to lay them, but a robot can do it. And a robot can do it over and over and over and over again. At that size, that's 4 blocks roughly to a square metre. So if you're laying at 300 blocks an hour, that's 75 square metres of wall every hour that comes up. That's more than 1 square metre a minute. So you can do it very quickly. You can do it very safely. There's no human in the construction zone. One of the things you might have noticed is we don't have mortar in our application of the bricks. We use a construction adhesive that we didn't invent. We've borrowed that from other people who are already using it in Europe. And we apply that to the underside of the brick just as it's laid. And we do that for a few reasons. It's very, very quick and easy to apply. It's much easier than water and mortar. It's much easier to control, but it also cures very, very quickly. So you can build your wall as high and as quickly as you want. You don't need to wait for the mortar to dry to get enough compressive strength to keep going up and up and up. It means you get structural wall, the house is built in one day, and the very next day the roof can go on. You don't have to wait for any drying or curing time. When we set about to develop this bricklaying robot, it became apparent we don't need to just invent a robot, a bricklaying robot. It became apparent we had to develop a stabilisation system. We call it the dynamic stabilisation technology. One of the reasons you don't see yet too much robotics in the outdoor construction world is because, well, construction is dirty, as was said before, but basically in construction you do a different thing at a different place every single day. A robot in a car manufacturing plant does literally the same thing over and over again, and it's calibrated and tuned to millimetres. But they do that because they know the environment doesn't change. When you go to a construction site, there's vibrations, there's wind, there's the machine movements itself. So when we want to place a brick at 35 metres through our boom at 1 millimetre precision, we had to develop a stabilisation system, which basically is the key behind our technology. It's the enabling technology. To do that, we need lasers. 1,000 times a second, we measure the end of the robot in 3-dimensional space, and we take that measurement and feed it back through our computers and our processors and use predictive algorithms, which are really AI, to adjust. Constantly measuring and adjusting 1,000 times a second, micro adjustments, which has the net effect of just being able to keep the end effector, the robot end effector, fixed in space to do whatever it needs to do. In this case, it's to lay a brick, but it could also be to lay a roof tile, or to apply paint onto the wall, or to put plaster, or to put a drill to drill a hole into the wall. Basically, to take robots outdoors, you need some sort of stabilisation if you're going to do things like this. We also had to develop, as part of the system, a through-the-boom delivery mechanism. Most robots in the factory setting just pick something and place it. They go back and forward like this. But when you're on a construction site, you don't want the booms slewing and swinging all around. You need to deliver the product through the booms so that you can just go like this. So we had quite a complex system we had to develop. In the end, we developed a shuttle system. So we have a little robotic shuttle that carries a brick from the start of the machine right through to the end to where it's laid. And then that empty shuttle, which has got a little battery in it and drives itself like a little roller coaster carriage, drives its empty shuttle back round to the start and picks up another brick, and it just goes round and round and round again. And that can equally be changed to put in a roof tile or other construction technology applications. What we want to see is these houses being built the same way that a car is built. We want to see these manufactured. So if you can build the walls in a day, then you can put the roof on in one day, the next day. And then you can put the windows on the next day. And it starts to become a conversation about days, not months and years, for houses to be built. There's all the ESG benefits that everyone's talked about.